Hello, welcome, and let us solve the question 6.5.3 from the work Mathematical Methods for Physicists by Arfken, Weber, and Harris. So the question states, assuming a unitary matrix U to satisfy an eigenvalue equation UC equal to lambda C, show that the eigenvalues of unitary vectors have unit magnitude. The same result hold for real orthogonal matrices. Alright, so I will just change my the notation form of U and C. I will just write it as let me just first write given as U matrix onto C lambda into C. So this is one, and lambda can be anything. Okay, it can be anything on the complex plane. Okay, now taking adjoint of equation 1, so that is nothing but U into C dagger equals to lambda into C dagger. Alright, so this gives me C into U dagger equals to lambda star C. Okay, that is 2. Now we multiply 1 and 2, so that gives me as the left hand side of it will be C vector U dagger U into C equals to lambda star lambda C C. Okay, and this will be nothing but lambda square. Alright, U into U is nothing but E, and E acting on any column vector will give the column vector itself. So it will be C lambda square. Okay, now bring this to left hand side, 1 minus lambda square so this will give me this will be equal to 0, and since my column vector is not 0, that is my C is not 0, then it's obvious that 1 minus lambda square will be 0, which implies my lambda 1 should be plus minus 1. The magnitude of my lambda should be plus minus 1. So my lambda can be anything complex, but at magnitude it's gonna be plus minus 1. Alright, so in other words, just extending this problem, I can write my lambda in some sort of e to the power I phi. Okay, so yeah, and for orthogonal matrices, let my orthogonal matrix be denoted by this theta. Okay, so C equals to lambda into C, and if I take transpose on both sides, or rather let me take adjoint on both sides, that will give me C orthogonal transpose lambda star into C. Okay, that is my 3 and 4. Multiplying 3 and 4, that gives me C wood dagger orthogonal matrix into C lambda star lambda C inner product of C. Okay, so one thing one must remember, that the Hermitian adjoint of any orthogonal matrix is Hermitian conjugate of any orthogonal matrix is nothing but the transpose of that matrix, of that orthogonal matrix. Okay, I will put this property over here. C O orthogonal transpose into orthogonal matrix into C, lambda square C into C. Alright, and another property of orthogonal matrix is O into O transpose equals to O transpose into O equals to E. Now it's kind of a similar to the unitary matrix, and I will put this into the previous equation over here. Alright, so that will give me and once again I will come to a point where I have my mod of lambda equals to plus minus 1. I hope I could explain this question. Thank you for watching the video.